All right, well, we'll go ahead and get started. Today we're going to cover briefly number systems. We use different number systems to represent numbers in different ways. I don't know. Where? Oh, don't do this to me. Let's try this. Well, that's not going to work. All right. Let's see here. Why is this not working? There we go. We use numbers to different number systems to represent numbers in different ways. The two most commonly used number systems that we use on a daily basis are base 10, because we have 10 fingers, and for historical reasons we use base 60 to tell time, where you count up to 60 in one column and then you roll over to the minutes, 60 seconds, minute, 60 minutes, and you have an hour. So we use base 60, courtesy of the ancient Mesopotamians. But any number can be a base if it is greater than or equal to 2. Any number between 2 or above could be used as a base for a number system. Each number system has its own set of symbols. For the decimal, like I said, we use all the time. We have the 10 familiar symbols: 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. Now, the ancient Mesopotamians had 60 symbols for their base 60 number system, which I'm glad we don't still use those symbols, because that's a lot of memorization to remember 60 symbols. We'll get to binary later, but binary, which is base 2, has only 2 symbols, 0 and 1. So the number of symbols is equal to the base. The base equals the number of symbols used for that number system. Now, going back to first grade or kindergarten, what do you do when you run out of symbols? You add a column to the left. So, with counting, you go through the symbols, all the symbols, then you add a 1 you roll over to 0 and add 1 to the left. Yeah. Oh. That's with all number systems. So, reviewing from first grade or kindergarten, you go from 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, then roll over to 0 and add a 1 to the next column. Okay? If this is really a necessary review from first grade, I would be disappointed. But anyway, you adding 1, you continue adding 1, and you go through the symbols again in that first column, and so on and so forth. Now, what's going on with that is, say you have base n. Okay, the numbers, the symbols that you use for the, why are you racing on me now? The symbols that you use are in different positions. Come on now. The positions of the symbols represent how many of the n to the appropriate power of the position you have in the number. So, this is the equivalent of saying 3 times 10, if n equals 10, 3 times 10 to the 4th plus 8 times 10 to the 3rd plus 7 times 10 to the 2nd plus 3 times 10 to the 1st and plus 4 times 10 to the 0th. Or 30,000 plus 8,000 plus 700 plus 30 plus 4. That's how you break it down. And how you convert base n to base 10. Okay? So, say you have n equals 7 as an example. Okay? Bear with me a second here. So say n is equal to 7. And let's make this a little bit easier here. Make it 734. You have 7 times 7 to the second power plus 3 times 7 to the first power plus 4 times 7 to the 0th power. If you're dealing with base 7. Yeah. Yes. Yes. We cover the same this topic in digital logic as well. So, what's 7 times 49? 343? Is that right? Okay. 343 plus 3 times 7 is 21 plus 4 is 368. 368 base 10. This is base 7. You indicate the base by a subscript after the number. So you convert from base 7 or whatever base by multiplying the value of the number times the power of the position, the power of the base to the position number, and then add them up together. So that's the easy way of converting from a base other than 10 to base 10. To go the other direction, let's say we have a number in, let's see here, 243 in base 6. No, I'm sorry. Let's go. We're going the other direction. No. Yes. Say we're 243 base 10, and we want to go to base 6. Okay. How many times does you look at the powers of 6? 1, 6, 36. Probably won't need anything larger than that. Well, really? No. Okay. This is 6 to the 0, 6 to the 1, 6 to the 2. So how many times will 36 go into 243? Anybody got a calculator handy? 6.7? Or 6 or 7? Well, which? No, you round down. How many times? How many? 6. Okay, so you do 1, 0. Because 6 in base 6 is 1, 0, not 6, because your symbols are 0, 1, 2, 3, 4, and 5. See what I'm saying? Okay, so this would be 6 to the third power, which is what? What's 6 times 36? What's 6 times 36? 216? Okay, so that's the 216's place. Now, it went in there 216 times. So you now subtract that from your original number. And you get 727. Right? My basic math still working out? Okay. So 27, no 36s will go into 27. So you put a 0 in that position. And how many 6s will go into 27? 4. And you take that 24 away from the 36 to 27, leaves you with 3, and that's what you put in the ones position. So that's the number in base 6. Who here has not had digital logic or is not taking it at this time? Oh, okay. There's quite a few of you. Okay. But we spend a little bit more time on it in on this in digital logic. I'm sorry? You subtract 24, 4 times 6. You subtract the 24 from the 27 and you get 3. And that is the 3 that you put in the ones position. That's basically about it. That's how you convert from one base to another. It's another base that you run into. If you're dealing with old systems, like from the 70s and 80s, octal is base 8. So say you have an octal number 372, base 8. Make sure you indicate that. That's 3 times 64. The 64's position here, the 8's position here, and the 1's position here. So 3 times 64 plus 7 times 8 plus 2 times 1. So that should be, what is that, 192 plus 56 plus 2, 250? Yeah. Equals 250 base 10. Like I said, base 8 is not used in modern computers anymore, but it was used in some computers prior to the 1980s. So if you're dealing with a legacy system, you might run into octal, and just know that that's base 8 Some scientific calculators still will convert octal to decimal and back for you. TI scientific calculators do not typically have number base conversion functions on them. Casio scientific calculators do, which I don't know why TI doesn't do that, but neither here nor there. But your better scientific calculators will be able to do those number conversions for you. Let's see here. What time is it getting to be? 4:44. All right. This wraps it up for the general number systems. We'll cover binary on Monday and hexadecimal on, no, I'm sorry, binary on Wednesday. No class on Monday. And then the following Monday, we'll cover hexadecimal.